Hi, welcome back to Dr. VASU'S lectures. In continuation of C language, we are going to see the character and Boolean type data types, right? So, characters. We know the characters are, right? It is represented by CHAR. It is for display purpose or for you to use or to declare. CHAR is used for character data type. It's 8-bit long. It takes 8 bits to store that information. And here, there are different types of characters. Signed character, in the sense, it can be a negative or positive signed character. It ranges from -128 to 120. You may ask, what are these values? Here, let us see. This computer can understand only the numbers, not these characters. ABCD doesn't know, right? It doesn't know anything about letters or characters or things. So, to indicate them in the form of numbers, we have a coding. ASCII, we have called ASCII numbers, and let us see that. I will tell you. Also, unsigned characters, no sign for it. It ranges from, its values range from 0 to 255. These numbers we will see, they are the, basing on ASCII numbers, we got it. Next. Let us see, let us take a simple program to display a character, a simple character. S is assigned to A. A is a variable. And it is a character. We have declared it as a character. And now, to display this character, this variable A, what A can hold any value, right? It can be character S or C or D or X, whatever it is. So to display, we use %C here. So character A is how much? Well, let us see how it is displayed. So complete the program and let us see the output character A is equal to S. So this character, only a single character can be used. It can be a number, a special character, or a capital letter or small letter, whatever it is. They are indicated by %C form. So let us see. If you take another program, I have taken 3 characters here. Character A is declared as a colon, B is @ symbol, and C is $, also D is 0. Let us see how they are displayed. For any character, whatever it is, to display %C is used. Here in this place, I want A value, right? Similarly, B, C, D. All these 4 characters are to be displayed here. So if you compile and execute this program, we get character A is equal to colon, right? This is the colon here. And similarly, B is @ symbol, and C is $, and D is 0. So like this, these characters, even special characters or numbers, all these are displayed using %C only. Coming to the range of values, these characters can be, as we have seen, it is declared as a character or signed character or unsigned character. The range is 2 power -n to 2 power n-1 -1. That is -128 to +127. These values actually, all these numbers, 0 to 255, totally 256 numbers. They can be, they are actually divided into 2, half. Half of it is shown in the negative side and half in the positive side, like this. So totally 256 characters can be shown. So here, these are the range of these numbers. When you are coming to unsigned, all the numbers are falling, 256 numbers are falling from 0 to 255. Okay. So all these, whatever, whether it is a signed or unsigned or character, they need a memory of just 1 byte. Okay. 1 byte is sufficient. So characters, and as I'm telling, Here these ASCII values are given to these characters. 0 to 9, we have 10 numbers, and 0 is given a character or a ASCII value of 48. Similarly, 1, 49, 2, 50, like that. So like this, the values, ASCII values are assigned. Next, capital letters. A to Z, we have 26 characters. A is, capital A is given 65, right? ASCII value is 65, B 66, C 67, like that. Small letters, A to Z. Again, these are 26 in number, and small a is 97, B is 98, like this, C 99. Special characters also given those numbers. The special characters can be a hash, colon, plus, minus, all these symbols. They can be 150 in number, and hash is given a ASCII value of 35. Like this, all these special symbols also are assigned ASCII values like this. Okay. Now, so characters. Like in coming to these, I have taken different variables. Character A indicates is assigned capital A, B capital Z, C small a, D small z. Okay, let us see. I want to get the ASCII value of a character A. A is small a, capital A. This A is, small a is the variable, and it is actually indicating capital A. So character is equal to %C. In the sense, here this value comes percent. In this place, we get the value of A, that is capital A. Its ASCII value, because it is a value, we have to declare it as an integer. So that's why %D is taken. So %D is indicated here. We want the ASCII value of what? A. A is nothing but capital A. This A is a variable. This actually is denoting capital A here in this. So ASCII value of capital A should come here. Similarly, B, the character B here, character B means here it is Z. So capital Z and its ASCII value. Similarly, C, D. Let us see, compile this program and execute this program. Let us see how the output will be. So if you take the character A is indicated here, as we have seen already, its ASCII value is 65. A is 65. Z is 90. In between, B is 66. Like this you get. So small a, character small a, ASCII value is 97. Similarly, small z, 122. All these A to Z, in between all the letters fall between this 97 and 122. So like this, the ASCII value of these characters also can be obtained. Next comes Boolean. To store 0 and 1, we need Boolean variables. It is indicated as underscore bool. 0. Actually, the meaning of it is why the 0 and 1. They indicate the position of a condition, whether it is switched on or off, whether it is true or false. If it is false, it is indicated as 0. Or it is switched off, it is indicated as 0. If it is true, then it is indicated 1. In switch on condition also, it is indicated as 1. So here, to use this, we need to use stdbool.h header file. When you want to utilize these Boolean operations, Boolean operations, we need to add the header file in the beginning. So that is stdbool.h. So include stdbool.h. If you say a simple program, so you have included in addition to stdio.h, stdbool.h also is added. And coming to this, we are declaring A as 0 and B as 1. And let us see how it is indicated. Because these are just numbers, we can use them as or treat them as integers. That's why %i is used. So character A is equal to %i. It means A value comes here, means 0. Similarly, B should come here, 1. Let us see, compile this and execute. Oh, you get character A is equal to 0 because this A indicates 0. B indicates 1. So this is the output of the display we get. Okay. So these are the character and Boolean type of operation, variable data types we have seen. In the next, we'll see output of or display of data items clearly in the next video. Don't forget to subscribe Dr. Vasu's lectures. Thank you.